While preparing for this video, a lot of interviewers told me that currying is the topic whose questions are the one a lot of candidates fail to answer, just because they don't know how it exactly works or don't have their basics right. So what is this currying anyway? Currying is a function that takes one argument at a time and returns a new function expecting the next argument. It is a conversion of functions from callable as this into callable as this. And curried functions are constructed by chaining closures by immediately returning their inner function simultaneously. So if you haven't watched the last video of this series, which was on closures, you can watch that video by clicking on link in the description or I button above. Now don't worry if you're unable to understand what I just explained. By the end of this video, you'll be able to answer most of the questions that can be formed on currying. So let's understand it with an example. Okay, so I've opened VS Code over here with basic HTML, CSS, and JavaScript files. And let's understand currying with this simple example. So as I mentioned, we have a function f with params a, comma b, and it prints a, comma b. So when we convert this type of normal function into this type of format, this is called currying. So let's see how we can do that. So instead of writing this, we can write a function f with param a. And as I mentioned, in currying, a function takes one argument at a time and returns a new function expecting the next argument. So we're gonna return a new function. We're gonna keep it as anonymous function with no name and with the b parameter. And inside of this, we're just gonna simply console log a, comma b, just like before. Okay, let's try to run this. I'm gonna console log function with value 5. Let's see what do we get when we run this much of the code. So let me run this by opening with live server. There we go. Let's go to the console. And in the console, you can see we get another function over here. So how do we run this? We can go over here, and since this is returning us a function, what we can do is we can call it just like this with something else. So let's say if I enter 6 over here, let's see what do we get. But you know what, instead of this, I'm just gonna say return with a and b, just like that. So, and without this, we get this function returned to us. So yeah, this is how currying works. This is how we convert a normal function into a function which is curried. There can be a lot of levels to this. We can have more parentheses over here just like this. So it depends on how deep the currying is. And we're going to discuss all the types of questions that interviewers can ask you during the interview process. Now there's an interview question where interviewer can ask you, why do we use currying? So there can be a lot of answer to this question. To avoid passing the same variable again and again, to create higher order functions, to make your function pure and less prone to errors. So actually this is more of a theory question. So instead of making this video too long, I've written a blog on currying, which you can check out by clicking the link in the description below and follow along with this video. In that blog, I've included a lot of theory questions and all of the interview questions that I'm going to discuss in this video as we move along. So definitely go and check out that blog with link in the description below. Alright, so let's get down to our first question, which is how will you implement this sum function like this? And what this function should do is this function should sum all of the parameters that are provided to this parenthesis. So this is actually very similar to the example that I discussed a few minutes ago. So I will highly recommend you to go and try this question yourself first. So pause the video right now and try this question yourself and then continue with this video. So I hope you are able to solve this question. Let's go and understand how we can do this. So as I explained to you, we have a function first. Let's go from scratch. So how I would explain this question to the interviewer is, so I'll go and explain by creating a normal function first, sum with 3 parameters, let's say a, b, and c, and return a plus b plus c, just like that. And if we go and console log this, sum, let's say 2, 6, 1. So we'll obviously get the output 9. But how do we implement it? Just like this. So right below this, actually I'm going to comment it out first. Yeah, below this, I'm going to create another function, sum, which takes a, and inside of this, as we already discussed, in curring, a function takes one argument at a time and returns a new function expecting the next argument. We're going to create a new function which will give us another argument. So I'm going to create a function, an anonymous function with parameter of b. And after that, I'm going to create, since we have another parameter over here, another parenthesis, so I'm going to return another function with c. Oops, c. And inside of this, finally, we can return our answer, which is going to be a plus b plus c. Now, if we go on and run this, sum 2, and then 6, and then 1, and go and check it out. Yep, we got the same output. Now, if you want to explain this in much more in depth to the interviewer, you can explain this just the way I explained you. So you can start by one parameter. You can say that if we provide it 2, then it's going to return us a function which is going to expect another parameter b. And when we provide it b, which let's say we provide 6, that's going to expect another parameter which is c. So we're going to provide it the third parameter as well, and then we are going to get the final answer, which is going to be a plus b plus c. Alright, so our next question is this. We need to create a function called evaluate, and we provide it a parameter of sum, multiply, divide, or subtract. So we can provide this either of these operations, and after that we're going to provide it to parameters over here which are going to give us result according to this. So if this is sum, this is going to add this. If this is multiply, this is going to multiply this, and so on. So we're going to go on and create a function over here called evaluate. And first thing that is going to be taking is this type of operation. So I'm going to give this operation parameter, and inside of this is obviously going to return another function because it is expecting another argument. So we're going to provide it, we're going to return another function which is going to be anonymous function, and I'm going to give this, let's say, a, and inside of this it's going to be expecting another parameter. So I'm going to return another function which is going to have a parameter b. And now inside of this, with respect to this operation, we're going to give the output. So I'm going to check if operation is equals to sum, then return a plus b, and so on. So let me write this quickly, just like that. Otherwise, let's return, if none of the operations are there, then I'm just gonna return invalid operation. Cool. All right, let's try to run this. So I'm gonna say evaluate, and I'm gonna write sum over here, and I'm gonna provide this, let's say 4 and 2. Let's see what do we get. Oh, I need to console log this. All right, we got 6 over here. Let's see, we will try to give this multiply. Okay, we got multiply. Okay, so you can write this actually in some other way as well. So I'm gonna create a const mul, and I'm gonna provide this evaluate multiply. So this is one of the use cases of curring. Since we have provided this multiply over here, this will always perform multiply. So you can reuse this n number of times. So if I go on console log mul, and mult will obviously will have this function returned to it. So we can say 3, 5, which should give us 15, and we can reuse it again. Let's say 2 and 6, which should give us 12. So we should have 15 and 12 as an output. Yep, just like that. So you see, this is one of the use cases of curring, that we initialized our function once with multiply or whatever that we wanted to. So we're not initializing it again and again by providing multiply every time we call this. So we just provided it and initialized it once, and now we can use this mul function over here to multiply these numbers again and again. So during the interview, you can explain all of these things to the interviewer, and the interviewer will really be impressed. Now our next question is on infinite curring. So what is infinite curring? So interviewer will ask us to write a function which we can call just like this with n number of parameters. So if you have a function like this sum, and we can say 1 and 2, so this should give us 3. But we can also call this function like this. We can add 4, 5, or we can add n number of parameters after this. And this should be flexible according to the number of parameters and should give us the answer accordingly, which in this case is going to be 12. So how do we do this? So this question was actually asked to me during my Cast 24 interview, and I've already discussed in this Cast 24 interview experience video. So I'm going to go on and play that clip right here. So the interviewer provided me with this code snippet and he asked me to implement this add function. So let's see how we can implement that. So we create a function called add and it takes a parameter. Let's say a. Okay, so we have a bunch of parameters over here. So it's obviously going to return a function. Then we are going to call that function with another parameter, So it can go infinite, right? It's just not that we have to implement it till 5, 2, 4, 5, and then that's it, because that will be easy, right? So let me remove this complexity for now. And I'm just going to implement with just 2 parameters. So this function a, and it's obviously going to return a function. So I'm going to say return function b, let's say, or let's say anonymous function, and it's going to take b, and then inside of it, I'm just going to return another function, which will have, let's say, a plus b. Okay. Right. So now if we go on and execute this, you're going to see we get the output as 7. Yep, just like that. But we don't want that. We don't want this much complexity, right? So we want to write a code which works infinitely. So if I, let's say, go on and add 4 and 8 over here, this should adapt to that code. So what I'm going to do, I'm going to remove this inner function and I'm going to say we have 2 of these. But then I'm going to check if we have any more params or not. So I'll check if b has a param, then just return this add again. I'm just going to provide the value of a plus b and just continue this. So a plus b, and that's it. But if b doesn't have any value inside of it, that means it's coming to an end. So I'm just gonna return a. So let me explain this again to you. So let's say we have 5, 2, 4, 8 over here. So first of all, we provided it with the 5 and it returned us a function. Okay. So then we again called it with 2. We called b with the 2. But if it's going to check if 2 is there or not, if there is some value inside of b or not, only then it's going to return the addition. Otherwise, it's just going to return the initial 5 value, the sum of those numbers up until that point. So okay, so we did have 2 at that point. So we said, okay, if 2 is there, then return a plus b. So 5 plus 2 was returned. So 5 plus 2, that is 7, went inside of this function. So now its value is 7 over here. But then again, it's going to return another function. Then it's going to check if we are calling that function as empty. But no, this is not empty. It has 4 inside of it. So then again, it's going to check if there's something inside of the b, then return a plus b. So at this point, a's value was 7. So it's going to say 7 plus 4, that is 11. So it's going to pass 11 to that. So this cycle will run again and again and again until we reach this point. So up until this point, the value was 19. So then it's going to have a 19 value over here and it's going to return a function again, and then it's going to check if b has something, but here b doesn't have anything. So it's not going to go inside of it and it's just going to return a, that is 19 from here. So our answer is going to be 19. Yep, we got this output over here. Now the next question that the interviewer can ask you is the difference between currying and partial application. Now what is this partial application? Let's see. Now you may have started to think that the number of nested functions a curried function has depends on the number of arguments it receives. And yes, that is what makes it a curry. Let's take some example. So if we have a function sum with a and it returns another function which has b comma c, and then they return a plus b plus c, just like that. And this can be called like this. And we provided 10, and then we can call x like this. Let me console log this. Or it can be called as sum. It can be called directly as. So you get it what I'm trying to explain, right? So it can be called in either of these ways. So you get what I'm trying to explain, right? It can be called in either of this or these ways. So these function expect 3 arguments and has 2 nested functions, unlike our previous version that expects 3 argument and has 3 nesting functions. So the first question that we discussed, in which the sum had 3 nesting functions and had 3 arguments. So that is what our statement was, right? That the number of nested functions a curried function has depends on the number of arguments it received. But in this case, that is not the case. In this case, we have 3 arguments, but we are only returning 2 functions over here. So this right here is not currying. We just did a partial application for this sum function. What partial application does is, partial application transform a function into another function with small arity. Also, if you don't know, arity just means the number of operands or the arguments a function receives. So if we were to write this same function with currying, we would have written it something like this. Because in this, we have 3 arguments and we are returning 3 functions. But in this, we have 3 arguments, but we are returning only 2 functions. So that is the difference between currying and partial application. This right here is partial application. Now, in some cases, interviewer can ask you to explain a real world scenario for using currying while developing our web applications. We can actually use currying to manipulate our DOM as well. So let me give you an example right here. And you can give the same example to your interviewer as well. So I'm going to go to the HTML file and I'm going to add another h1 tag over here called hello Piyush. And here it is. Now I'm going to go to our JavaScript file. So right here, I'm going to create a function called update element text, and this is going to take an ID. And inside of this, I'm going to create another function which will take content. And inside of this, I'm just going to write document dot query selector, and I'm going to provide this the ID hashtag ID. Oops, just like that. Dot, and I'm going to update the text content to be the content provided right over here. Now, what we can do is, since we have an ID over here, oops, I haven't provided the ID. So let me give this ID of heading. Let's take this ID. Now what we can do over here is we can just initialize this function with our ID once, and we can update the text of our heading again and again by calling this the function that will be returned from this. So let me show you. So const update header, and I'm gonna call update element text, and I'm gonna provide this heading ID. Now we can use this update header again and again every time we want to update the text inside of this heading right over here. So let me show you. I'm just gonna call update header right here, and I'm gonna say hello roadside coder, and let's see. Yep, you see we have updated it, or we can write subscribe to roadside coder, and you see it has been updated. So yeah, we can use this function again and again in our code according to, let's say, the condition. If we click on a button, we can call this function again and again. We don't need to use query selector again and again by providing it the ID. We just need to initialize it once, and we can use it just like this. So yeah, you can give this answer to your interviewer, and they will definitely be impressed and think that you have used currying in your apps before. Now, do you remember in the beginning of this video, I gave you an example on how we can convert a function like this into this? And this is what a curried function is. So how about we write a function called curry, which converts this function into this function? Now this is the most important question of this video. Now this question is usually asked during the senior interviews, but can sometimes be asked during junior interviews as well. So let's write a function called curry, which converts a normal function into a curried function. So I'm going to write function curry. And this is obviously going to take a function. So I'm going to provide a function right here. And this is going to return us a curried function, which will look something like this. So I'm going to return curried function, or just curried func. So this is going to take all of the arguments of the function in the form of the array. So args right here will be the array of all of the arguments. So what we'll do over here is I'm going to check if function dot length is more than equals to args dot length. So that is what currying is, right? If the function dot length is equals to args dot length, because the number of argument has to be the equals to the number of functions returned. So if it's not equal, then what we'll do is this is actually our base case to check. If it's not, Then we're gonna return a func with args. Else we will return a function which will collect all of the next arguments that are going to be returned to us, spreading the values of the arguments first and then the next arguments, calling the curried func recursively. So let me show you. It's going to be a little confusing, but don't worry, I'm going to explain you after writing this whole thing. So let me write this out first. So return function with all of the next arguments, and inside of this I'm going to call this curried func with args and of the next arguments until this becomes more than all of the arguments of function length. So yeah, let's test this out and I'm going to explain to you after that. So we have a function sum over here, and inside of this curry function we're going to provide this sum function right over here, and inside of this total sum we will have this curried func. Now this thing will be a curried function, so I'm going to call it just like this. So let's see, we should get the output. Oops, I made a mistake over here. So I'm gonna check if args.length is more than equals function.length. Yeah, now let's see. So yeah, we get this output 6. Now let's understand how this whole thing is working. So we've created a function sum over here, right, which takes 4 arguments and it calculates the sum for it. Okay. Then we have created a variable total sum over here, and we're passing this sum function to this curry implementation that we have done right over here. Okay, cool. Then we're calling this total sum just like this in a curried way. So let's see what's happening. We've provided this 1 to this. So obviously when we do this, this is going to return us a function which is going to be this curried func, right? So we have supplied it 1 first of all. So 1 will be supplied to it. Then it goes inside of it. It's going to check args.length. So args length right now is just 1. So let me show you. If I go on console log and I'm going to say args.length, and I'll also do func.length. Oops. First time the number of arguments were 1 and length of the function was 4. That is these 4 functions. Second time the length of argument was 2, then 3, then 4, and the moment the number of argument exceeded, it's gonna call this function right over here with all of the arguments. So I'm gonna explain you as we move along. So let's do this step by step. So I'm gonna comment this line now. So yeah, first time we have called it with this 1. So it's gonna check args.length. So args.length right now is 1, obviously. It's not more than the function.length, so it's not gonna go inside of it, and it's gonna go over here. Now this is going to call this curried func over here recursively. So what this will do is this will return us a function expecting next arguments. So if I remove this for now and run this, you're going to see that it returns us another function which is expecting the next arguments, because obviously the criteria for this is not satisfied. Currying means the number of arguments should be equal to number of functions, and the number of function has to be 4. Since the number of arguments are 4, the number of functions are also supposed to be 4. Only then this is going to run. So if we provide it another, let's say 6, then again it's going to expect the next arguments, because then it's gonna go over here with 6, and now args.length is 2. So over here it's gonna check args.length 2 is not more than function.length. Okay, so it's not going to go over here. It's going to come again over here. So in the case of third argument as well, it's going to again expect you to supply the next functions. But the moment we supply it with the fourth argument, so what it's going to do, it's going to take all of these and provide it to this sum function. That is this function right over here. And when we run this, you're going to see we have successfully calculated the sum for all 4 of these. Now you can write any function over here and this is going to make it a curried function. This is how much powerful this function is. Now I know this is a little bit confusing to you, but try to rewind the video and rewatch my explanation that I did just now. You'll be able to understand it properly. Also, if you would like to understand this question in a written format, you can click the link in the description and read the blog for this video. And also in my blog, I have included one more bonus interview question, which is very rarely asked, but is asked in really senior developer interviews. So you can go and check out that question in our blog. Link will be in the description below. So yeah, that was currying in JavaScript. And if you like this video, give this video a huge fat thumbs up and subscribe to the channel for more such awesome interview videos.